Thank you so much, Kevin. It's a pleasure to be here. We've been producing quantum and art events at YQI, the Yale Quantum Institute, since 2018, and the festival have been really an amazing partners for us in this. So we are very excited to present you today this event. That's going to be half of it will be the screening of a documentary, Serena Campini. I forgot the title already. I was practicing my Italian, but it was terrible. Lo spazio oltre, also the space beyond. So we'll start with this movie, and then we'll have a conversation with all of us. I realized that we started sitting here, but we should probably go in the audience for the movie. So without further ado, we'll play the movie. Thank you all.
I was working with memories, I was working with transparencies, and I was focusing my attention on the study of form as an organizational pattern of cellular structures. So I was looking for a partner supporting me to observe through the process of imaging the brain.
One of the defining paths for my professional career has been to try to bridge multiple levels of analysis in the nervous system. Actually, my original training was in behavior and what we might call systems neuroscience, trying to appreciate the nervous system and the brain as a large collection of pieces that are all necessary to work together in orchestra, perhaps. And my later training, in fact, was to dive down to a very small level of these individual synapses, these individual connections between single neurons.
Neurons observed by means of fluorescence scanning visually corresponded to a rhythm that I have always been searching for. By means of your lab's scanning, that rhythm emerges through light.
In biology, in neuroscience in particular, we use light not only to monitor the activity of the brain and of individual brain cells, but now we can use light to manipulate brain cells, to actually change their activity and develop experimental manipulations that let us test hypotheses of how activity in the brain drives behavior all through light.
In fact, as opposed to simple static views of their structures, your lab's microscopy allowed me to observe the activity of neurons and the conversations taking place among them. Actually, your original in vivo videos allowed me to step into the movement, creating a pattern that was done with layer and layer of maybe more than 3,000 photograms of neurons activity. Your models are chromatically processed for a faithful reproduction of their visual rhythm. And within the paper structures or in the long scrolls, images appear as small figures drawn just with China ink, often inspired by the lumps of paint or by the stance of the preparatory acid, rapidly executed with another layer of paper so that they can float and move upon the painting and not being too much, as we said, crystallized.
Could see between the one cell and the other just a little bit of space.
Yeah, the space between the cells. I try to be very, very faithful to, so that the rhythm, the morphological rhythm of the cell was respected into every single spine, which was since the beginning one point that we discussed it very much.
From there, this is amazing creation. quite a bit of advantage of these new approaches with a number of ways where we can harness the power of genetics to drive individual neurons to express molecules, proteins that light up when the cell is active, that not only give us a view to the shape, to the morphology of the cell, but actually give us a readout as to the activity of the cell itself, that fluctuations in light tell us something about the fluctuations in the neuron's activity, and perhaps fluctuations in our own thoughts and our own behaviors.
When you stay in the process of intuition, you discover that it is a sort of practice, a sort of vision ahead, to leave it open, to follow those fluctuations and the infinite possibilities of the mind, to consider even an interruption of thinking as such. We need to leave some empty space. To me, that I work with images, I need them to rest. I need to be sure that they can have a place where they fade into the white. They are allowed to disappear. And specifically with neurons is also a way to pay an homage to the images, but at the same time to leave the neurons, let's say, free to be like transistors of informations, but never crystallized into thoughts, as we were saying, like drawing upon glass.
And one of the challenges in science, especially at this moment in history, is to realize that I will almost certainly not be successful, that we know so little, that all I can do is take part in a very long journey, of which I think we're at the beginning of. But I wonder a little bit whether or not that's not similar in some ways to an artist in simply trying to get the vision that's in your head out.
Serena, would you like to introduce yourself a little bit?
Sure. Thank you. Thank you, Florian. Thank you, everybody, to be here this afternoon. It's a joy to be here, and I'm glad that I've been introduced so well from my work itself. I'm a visual artist, an art historian, and I'm here to work as an artist in residency at the Yale Quantum Institute. My presence here wouldn't have been possible without my long collaboration and friendship with Michael Higley. So it has been a great joy, and thank you.
So then we'll skip you, Michael. We'll go back. We'll talk to Harsh. Would you mind introducing yourself?
Hello. Hi, I'm Harsh. I am a rising fifth-year student, a PhD student. Am primarily advised by Shruti Puri, who's part of the Yale Quantum Institute, and also Rob Shokoff, who's also who's the director actually of the Quantum Institute. My work is mainly on quantum error correction, so that's primarily what we've been collaborating on. And so we are trying to find ways to extend the memory of quantum information. So as you might have seen in the documentary, quantum information is very fragile and gets affected by a lot of noise. And so we're trying to mitigate that noise and also correct for that noise. And so that's kind of the focus of my work. And it has been a pleasure to work with Serena. Thank you.
Up next, Michael Higley.
Thank you all for coming today. It's really an enormous pleasure to be here.
So I'm a neuroscientist here at the medical school. My lab is largely focused on the function and the structure of these synapses that you heard a little bit about. These are the connections between brain cells that are intimately involved in the formation of memories and even just in our sort of normal thought process, our cognitive abilities and so forth. And so it's been an enormous pleasure to work with Serena. Really, I mean, this is entirely her work. I provided a few images, but it's been absolutely amazing to see what she's done with it, and also to see the evolution of the project as her work continued with the YQI here as well. And in fact, some of the similarities that we've observed between the quantum world and between scientists' approach to quantum signaling, the similarities of that with some of the neuroscientific concepts that we explore at the medical school have been really super interesting, and happy to see those ideas continue to flourish.
Thank you. And last but not least, we have Donna Feddes.
Great. So I'm Donna Feddes. Thank you for all being here today. I'm happy to be here today, too, to learn from these really interesting folks. So I'm a gerontologist educator, and I use slides like the ones that were inspirational for Serena's work in a practical sense. So I teach workshops on many different issues of aging and caregiving and dementia. And I work with sort of the idea of neuroplasticity in workshops around brain health and what you can do to decrease your risk for cognitive illness, and then do a lot of training with people who have dementia as part of their life as a family caregiver, healthcare professionals, and so on, who work with older adults with cognitive impairment. So the idea of a physical representation like this is so thought-provoking to help people understand what's going on inside of their brain and give us ways to talk about strategies and things that we can do to help for maybe the grandparents, the individuals in our life who have cognitive illness.
Thank you all, and thank you all also for being here. So we have a lot of people on this panel that have very different jobs, and it has been really a pleasure to bring all of these people together the same way that the Arts and Ideas is mixing art and ideas. We are mixing art and science, neuroscience, quantum science. And so, Serena, can you tell us a bit more about your residency at YQI and what you've been doing?
Thank you. Yes, at the time I had the chance to meet with Florian and to start the project with the residency. It was really a joy to see how it was conceived, in the sense that to the artists is proposed, first of all, to stay very much focused on quantum theory, and so not just to study, that was a great pleasure, but also to share with people, with the researchers, with the scientists, and really to see the inside that are definitely in between different fields. So the first part of the residency was very much focused on this. And then the work itself reacts to this incredible vision that provokes the work to go ahead. So I had the joy to work with Harsh and to see that some of the paths were naturally growing to a new layer of work. My work was already very much multi-layered, as you can see also from the media I use, and starting from the hand making of the paper to the more plastic use of the body of the paintings, the fluid of the inks, till the very rarefied, dusty, natural pure pigment minerals. And so in the spectrum of different media, it's very natural for me to go deepening different densities also in the world around us. So I might say that coming from 12 years of work close to neurobiology, to have the chance to go within and to see and to perceive and to study and to get inspiration from the quantum world was really, really a great joy, and really something that touched the work practically. So the residency was very well, I think, structured, and I'm glad to be here now with you to talk about it.
And so that's perfect. Harsh, can you tell us a little bit more about like how does your work as a researcher impacted Serena as a researcher? Like what was your collaborative process?
Yeah, so you saw a few images on the screen, so maybe I'll talk a little bit about that. I guess the big goal is to make a new type of computer here, and we call that a quantum computer. And so that the quantum computer behaves on the fundamental rules of physics, which is quantum mechanics, and quantum mechanics has governed a lot of what we've done today, a lot of what we use today, such as like LEDs or even, your GPS system and stuff. But that isn't used to actually do the computation. It's used to assist the computation that we do, that we are very familiar with today. And so at the Yale Quantum Institute, a lot of pioneering work has led to the second quantum revolution, and that's the second quantum revolution we think of as using these fundamental physics principles to actually do the computation. And so that's kind of the big picture idea. And so eventually we hope to build a new type of computer which is much more powerful than the ones we have today. And this, we've imagined these quantum computers to have be very impactful in like drug discovery and in a lot of different types of fundamental physics applications as well as like everyday applications. And so that's the big goal, but we're very, very far from that goal. And the one of the things that is currently standing in our way is that the quantum information is very fragile. And so it leaks out to the environment very easily, or it gets destroyed by undesired effects in the environment very quickly. And so the goal of my research is to extend that memory. And the way you do this is to correct for errors as they happen in the quantum computer. And so we call that quantum error correction. And at Yale here in like 2016 was the first successful demonstration of the quantum error correction. So the idea is that in order to do the error correction, you're probing the system over and over again, and that might actually introduce more errors, right? And so the question is, can you do the error correction in a way that helps you rather than harms you, because you're doing stuff to the system over and over again? And so in 2016, they demonstrated the full useful error correction where you actually had an extension of the lifetime of the information rather than it harming you. And so my work is particularly concerned with extending that scheme, which was introduced in 2016, and scaling it up. And so how do you make it bigger? How do you make more devices out of it? And so that's kind of the work that I'm concerned with. The way we do this error correction is to encode our information in a state of light that is very, very fragile, but we can study some properties of the light and ask a certain number of questions to the light and extract useful information or not, extract if we've had an error or not. And so these images of light, these are quite beautiful. And so Serena has made them into beautiful pieces of art. And so that's been the collaboration. I've, again, done very little for the artwork itself. I have just contributed some images, which Serena has then taken up and like made into beautiful pieces of art. But yeah.
And Serena, can you tell us a bit more about like your process on like reacting to this state of light?
Yes, like Harsh was providing me a tool that allows me to see the pattern, but not the pattern of the wave. It's like the pattern of the superposition of these states of light. So actually, I found them extremely beautiful. Besides, they are amazingly interesting. But the fact that he did, maybe you can tell better how the tool works, is that I can visualize them. And starting from them, I start to draw and to focus on that precious edge that is between the pure state of light, so when they can encode quantum memory, and it's natural dissolution that creates this sort of vortex. So this movement, it's really like, it was to me very touching because it was the same area that I was working with neuroscientific images, and even before, really in between the memory, its visions, and its very, as you said, fragile natural dissolution. Then physically, we had also the chance to develop a model that plays about this superposition, so where the particle is at the same time in a place A and B. We try to give an idea of how also symmetrical and meaningful is this superposition in a pure state of light, and then of course in its vortex that is goes back to the previous version, so it's reversible, and this is also a very interesting aspect that maybe can give us some sparks related to all these fields, because this idea of reversible, like losing but then coming back of the memory as in a way a similar lexicon to the human brain and to the human being experience.
And you're talking about the reversibility of losing memory in quantum computers, and it's also something that we can do in human, maybe? Can you tell us a little bit more about your practice on that, and like how can we help have longer memory maybe, or like at least coping with it?
I appreciate the connection, and I feel like that is what is very interesting to me, the idea of seeing what's going on internally and then thinking about how it relates to our day-to-day life. And I know from my years as a dementia educator and gerontologist that people care deeply about the things that are represented in this work. So the idea of how do we think, maintaining a connection to our capacity to think and maintaining access to our memories is essential to who we are as people. And so seeing Serena's work, it really brought up all of these kind of big existential questions for me, thinking, what is the meaning of our memories? What is going on internally? Who are we? What changes in our identity if we lose access to our memories? How do we continue to connect person to person if we don't have access to those shared memories? And I think this is very much important to people's fears. I can tell you that Alzheimer's disease is the number one fear for people 65 and older, and it's the number two fear for people of all ages, just behind cancer. So it's something that we're very, very concerned about. And yet, when we see how many interconnections there are and work in this field a little bit more deeply, there's so many other ways to continue to connect with folks regardless of their memory impairment, or regardless of if one neuron becomes incapacitated, maybe because of disease taking it over, or even a region of cells in the brain. And that's where I think it's really, really exciting. So, and I'll just say one other thing that Florian was mentioning to me, that in the quantum world, they sometimes borrow concepts from other disciplines and fields to help explain things. And to me, memory is just kind of a perfect crossover point for this, because so many folks think of memory as sort of yes or no. You either remember it or you don't, or maybe the memory comes back to you later, right? Or maybe it doesn't, and kind of this binary way. And that's actually far from the truth. So memory can exist in many places in the brain simultaneously, and knowing what's happening, because you can see a representation of it or think more about it. So if a person, for instance, has compromised short-term memory, maybe due to Alzheimer's disease, they still will retain access to their long-term memory for much longer. And so understanding a little bit about how this works can help you to time travel with them, kind of as they're floating through time, and connect in those long-term memories, because I'll have access to those for much longer. And it's really interesting. People can experience moments of lucidity. So there's a story I know of a woman who was visiting her mom in a nursing home. The woman had Alzheimer's. She was quite far along in her disease. She was nonverbal most of the time. So the daughter is going, visiting her, kind of chit-chatting about things going on in the family and their life. And she doesn't really think she's connecting or getting through to her mom. And all of a sudden she's like, I'm going to get going, Mom. And out of nowhere, the mother says, Kathy, why do you have to leave so soon? Just this perfectly lucid moment, extremely clear sentence. And I'm like, she's still in there. The pathways were blocked, but there was some spark. I could go on and on. There's ways to spark other connections with people based on art itself, based on music, based on sense memory, what you can smell, locations. There's lots of exciting things. And sort of, to me, the representations here are just an invitation to think more about those interconnections so we can continue to connect with folks who are important to us and our own identity as we age.
And speaking of using art to help us cope with maybe memory loss, we've been using art to try to explain difficult concepts and then going through either quantum physics but also neuroscience. And speaking of sparks and brain imaging, can you tell us a bit more about your collaboration with Michael at the WSI Institute and the...
Thank you. Yes, I think that as Donna was saying, this identity, and so it's a meaning also of perception and perception of the word itself was very much related to the first idea to go to visualize really the morphology of the cells. As we were saying in bearings with my curator, the idea that creates a sort of tautologic reaction in viewing neurons and viewing cells and in viewing the visual rhythm of the cells was very inspiring. And so at the beginning, the collaboration was mostly played here and there in a strong and very inspiring exchange of images that allows me to step into this inner rhythm of the cell itself and staying longer on their proportions or the distance between the spines or really trying to evoke that space that is continuously moving and creating those paths that, as you were saying, are familiar or sometimes are lost or sometimes you can find through another route. So our collaboration, I have to say, was precious and also growing through the time. And from the first exchange of ideas and concept and images, then we start to have a strong focus that gives also to the installation a more physical feeling also of the space within and of the space beyond.
And what was your experience with Serena, Michael? How do you manage running a lab, doing experiments, but also working with artists?
Carefully. So I was just thinking a little bit while Serena was talking. She reached out to me in I think maybe 2013 with an email that we still sort of joke about. But our interaction really persisted over email and exchange of images and so forth for I think a couple of years. We didn't actually meet in person until you had a show in New York. I don't remember, 2016, something like that. And so it was quite remarkable, in fact, to walk into a gallery in New York City and see images from my lab incorporated into these pieces that were there. That was quite stunning. But also, over the following years as well, it went from this email exchange to, in fact, our families have come to know each other, and we've gotten quite close outside of just this collaboration. And I was struck, while everyone was talking, that on the one hand, we start with this idea of synapses as being a space between two cells, but but really it's also the site of the connection between those cells. And as we grow, as we learn, your brains, even now while you're listening to us talk, right, are forming new connections that are the substrate of you maybe remembering something of today when you take it home with you. And all of us, under both healthy and sometimes unfortunately unhealthy conditions, have the experience of forgetting things, and some of that is also the loss of those connections. And so I was thinking about spaces over across computers and emails growing into more and more connections, not only between us, between our families, between those of us that are on stage here. I got to meet some of the quantum folks as Serena's project developed there. And so it's really been a steady accretion of connections between individuals in this community and even across the ocean. And perhaps to give one large shout out to this entire festival, right? I mean, this amazing process that we have in New Haven year after year that continues is really fundamentally about making connections between different fields, between different people. And so it's an incredible process that we all go through in different ways. But to be part of that, with these folks, and even, for a brief moment with you guys here today is really something special. And I mean, I think it reflects the work that all of us have done in various ways.
And so let's focus a little bit more about your actual work that you're going to be installing at YQI. And behind us, we have some more images of this. Harsh, would you mind walking us through the plot on the left? It's a quiz. It's actually your PhD exam right now.
Okay, I'll try my best.
And everybody needs to understand, so good luck.
Okay, no pressure. Firstly, I should say a big thank you to YQI to at least give me the opportunity to collaborate with Serena and have some of my work and the work of a lot of other people. I should say I'm not the only one working on this. A lot of other people, demonstrated in such beautiful fashion. So, just to reiterate, the big picture here is to extend the lifetime of quantum information. And so we encode this information in states of light, and in particular microwave light. So we're very familiar with optical light, the light that comes from the sun, the light comes from all these LED lamps and stuff. But if you just reduce the frequency of that light by several orders of magnitude, you get microwave light, which I guess you're all familiar with from your kitchen. But we sort of use them in our labs around the same frequency to and it behaves in a very similar way to optical light. And so we use that to encode information. So that the frequency of that light plays very well with electronics. Electronics that is used for Wi-Fi and stuff is about the same frequency. But we use it in a very different regime. We use it to encode quantum information. So on the left, this is kind of a state of light being distorted by effects from the environment. And what is shown here is, it's moving really quickly, but the four corners of this square that's kind of being distorted as time goes on are four different configurations in which we sort of store our information, but we're storing it simultaneously. We're not storing it maybe here at some point, maybe there at some point. It's actually all in four different places at once. And so those are the corners of the square. But nature dictates that if you store things at four different places at once, there's going to be some sort of interference, and so that's the beautiful pattern that you're seeing in blue and red in the center of the square. But then as this information interacts with nature, it gets distorted, and so the square is sort of kind of turning around. It is the pattern in the middle of the square is also being distorted, and that is its inevitable interaction with nature. So this is one of the ways that information is being destroyed. There's a lot of other ways. It can sort of also dissipate into the environment. It can radiate out, and there's various different ways the information is destroyed, and our goal is to find ways to preserve the information as long as possible, or at least as long as we can do something useful with it. And so that's kind of the goal of our research. The way we do this preservation is we choose very special states of light to encode our information in. And so this is one of those special states. There's various other ones, and this is the one that we're working on. This is actually the one that demonstrated a useful error correction for the very first time as well. And so, yeah, that's kind of a summary of the work.
Thank you. And so that very special state of light is the one that you fell in love with, Serena. And so that's sort of the next step on the slide.
Yes, that was the pure state, was the one of the one that I've been drawing and then engraving, in this case both on copper and aluminium. I want to stay with these materials that are also familiar with the lab, so superconductors. And starting from those path of the superposition visualized, I also been creating a space installation to try to step into this state of light. And as in all of my work, the papers elements, which are made handmade as copper or aluminium plates inside with this quantum information that is within and is not necessarily accessible, but it talks to the body of the work itself. And then I draw, and I have been painting more on this visual circle that is represented at the center of the states of light, and that I hope you are going to see at the Yale Quantum Institute. We are opening the show on Tuesday. And at this level, within the drawings, I try to evoke a little bit that natural osmotic exchange that is between nature and between actually every phenomenon of the universe. So within the drawings, I also put some of these, to me, metaphoric elements, like jellyfishes that are very much, exchanging with the surrounding. So this idea also of the environment that is giving an error to the system, but also embracing the memory, like the quantum memory is never lost. And so suggesting this idea that memory is never lost because it has always a physical storage, and it just goes from shape to its surrounding fluid, its surrounding environment, as well as neurons in their, let's say, ocean of thoughts. We have this shape within a strong connected world around.
And that's something that we've been fighting a little bit over. It's because you spent so much time engraving this beautiful pattern of like this perfect state of light. And the same way that researchers are trying to make the perfect quantum memory and encode information and fight against the environment, everything is trapped inside a system. So in the case of memory, brains, it's really hard to go inside without making some damages. Or like in quantum computers, you have this observer effect that like as soon as you interact with this, you lose the information. And so the same way you encapsulated all of this engraving into the paper. Can you tell us a bit more about this process of like trying to protect the pure state of light?
Well, in this case, I think that the geometric pattern is generally visible only from the top. When you get into an installation, as you saw in the movie, you have a three-dimensional installation that surrounds you, but then you have a geometric bidimensional version of it if you can look it from the top. So like putting this secret holographic information within all the pieces allows me to give it to kind of inform the art of this geometric layer that is also related to the harsh patterns and with the Kerr effect and pure state of light, like draw in single positions. And then I think this is also very familiar regarding what you were saying about the observer effect. So, like, we don't have to. We generally have this feeling that art is taking like ideas from an ideal world to a more concrete shape that is always so imperfect. So in the same way, I think that the geometric version is invisible. It's like the pure idea, the pure state, and then it is decline in different shapes that are always, more physical and more failing their form into the perception of the piece of art that you can have. Mm-hmm. That maybe is different from what the ideal was in your geometric vision.
Yeah, and then to give you a sense of the art coming up, we have some of the 3 points behind us. So Serena worked on this superposition series in New Haven. So we have this like multiple stages. So the shared identity will be on the green on Tuesday, and then this is really the blocking, the founding block of the information, the pure engraving. And then as we progress through the different installation, we have more like hanging elements on the ceilings and at the library, showing like some of the patterns and some of the emotion. And I think this is where the brain and all of the work that Serena has been doing with Michael on this program like comes back. It's not only quantum memory, but like it extends to this void. And so it has been really fascinating to work with Serena, and we encourage all of you to come on Tuesday to the tour. And so Serena will walk you through all of the different installations. And I can tell you that for how beautiful they are, they're extremely painful. I'm still bleeding from my hand wiring all of these things. So it's definitely physical memories on that in that case.